Hello friends, today we are discussing about the subject microprocessor in this lecture series, at which a serial parallel, a serial port communication, that is a serial communication in which we are seeing here the UART, that is the universal asynchronous receiver and transmissions. So in this communication, one of the protocol or one of the use we will say we are discussing here is the UART. UART is a universal asynchronous receiver and a transmitter. So this is a asynchronous receiver and a transmitter. It receives and it transmits also, but it is an asynchronous hardware that translates between a parallel and serial forms. It is a hardware that transmits between parallel and serial forms. Commonly used, this UART, which is commonly used in conjunction with the communication standards such as EIA, RS-232, RS-422, RS-485. So the figures which are shown here, the how a URA is work here. The receiver and a transmitter, its pin, data pin D0 to D7 are here. Okay. Read, write, interrupt, and clock signals are there. UART protocol, each character is sent as a logic low start bit. Each character in this communication, it has a start bit, it has a stop bit. The start bit, which is a logic low, and a stop bit, which is a logic high. A configurable number of data bits. The number of data bits which are transmitted are configurable, usually 7, 8, or sometimes the 5 bits are there. It has an optional priority bit. We know that a priority bit is there. The working of this priority bit is that whenever a message having a priority, according to that a message get a service. Means if a higher priority there, the message will serve earlier as compared to the others. So but here in this, a priority bit is set as an optional with the particular timing board. Means transmission is done with a particular bit timings. A timing is there for that the clock signals are there. So here we are seeing the examples for a escalator W. Okay, so which will get converted into the binary form 1010111. So how this escalator W is transmitted on a UART? It has a low start bit and high stop bit. Okay, after the start bit, which is active low, the next bits are sent 111, which is at the active high. So again the 0, which is low, again the 1, which is active high, 10, which is active low, and again a 1. Okay, after the 1 there is a priority bit. Okay, the 0 is a priority bit, and after the priority bit there is a stop bit, which indicates that start and stop bit are there. The start bit indicates that a message is started, and the stop bit indicates that a message is stop here. So that means the content of the message is end here. So the receiver can able to rectify the from where this particular message is started and from where up to where this particular message is ends, to recognize that a start bit and a stop bits are there. It has a least significant bits are there. UART hardware connection, how the hardware connections is done here. Okay, transmitter and a receiver. Okay, one transmitter is connected to the another device receiver, and another device transmitter connected to the another device receiver. So the receiver get connected to the transmitter and transmitter get connected to the receiver. This is how two devices communicate with each other. A transmitter can send a data, whereas another device receiver can receive a data. Whereas if a device A and B are communicating, in case here, okay, so we can say that a device A receiver is connected with a device B transmitter, and a device A transmitter connected with a device B receiver. So communication between device A and B can be possible as it has a transmission line which transmits the data. So whereas a B having a receiver, it receives a data. If a B having some data, it uses its own transmitter to transmit a data for a receiver B. So in this way, the communication or connections are made. Ground line is connected with a ground line. Character reception, how characters are received in a UART. Uh, a UART, it says start bit is there. It says whenever a start bit is received to the receiver, it comes to know that data is receiving. The start bit sets a character is coming and receiver resets its timer. Okay, so the receiver resets its timer. Resets it simple in the middle of the bits. So after the start bit, the receiver receives the bits till the stop bits. Till when it comes across a stop bit, a receiver stop the receiving of the bits. So the receiver uses the timer to time when it samples. A transmission rate must be known. So for that, a transmission rate must be known for the receiver. Okay, so that's why the receiver resets its timer so that it can able to cope up with a receiver's transmitter, sender's transmitter. The character reception, if a receiver samples too quickly, what happens if a receivers are sampled too quickly? Whenever there is a start bit, it starts the receiving the bits till it comes across a stop bit. If a receiver samples too slowly, if a receiver samples too slowly, so the clock is not matched with the and it will go beyond. Okay, see here, if a receiver samples too quickly means here the bits has to be sent transmitted at a faster level, so the last bit remains received earlier and after that a stop bit is there. Okay, so this is a start bit and all bits are sent at the higher level, means these the bits are transmitted at the faster or so quickly, so there is an empty space remaining at the end. So here we see if a receiver samples too slowly, if a receiver samples too slowly, that means it's when a receiver receives a start bit, it comes across all the bits. If a receiver receives the bit slowly, so it can goes beyond and within the clock time, the receiver can't able to receive the packets. So where the stop bit is there, at that time also it comes across a single bit which has to be received. So the receiver synchronization on every start bit only has to accurate enough to read a 9 bits. So that's why the synchronization is there. After each transmission, a clock of the device is synchronized so that a receiving and a transmission done at a proper sampling rates. UART character reception. Receivers also vary by the stop bit if a one, if not, report the framing error to the host system. If a receiver verifies the stop bit. If a stop bit is not found or a stop bit is zero, so it will reports a framing error to the host. So what is the framing error? We are sending a one frame, that is a chunk of the bits, 8 bits, 7 bit or the 5 bits. These are the chunk of the bits, we can say the frames. In another communication system, we can see it as a frame. So the error which is occurred in these frames are known as an framing errors. The new start bit can appear immediately after the stop bit. Start bit can appear immediately after the stop bit. Receiver will synchronize on each start bit. Okay, so the receiver will synchronize on each start bit so that they can able to receive a data within a time limit. Transmitter or a handshaking or a system handshaking. So the system asserts send and holds it high when it wants to send a data or a byte. Okay, the three-way handshaking system is there a transmitter system or a system handshaking? How the system handshaking is there? System wants to send a data, it will send a start bit. UART asserts a busy signal in response. It says asserts a busy signal when a UART finishes the transport. UART asserts the busy signals. So whenever a UART finishes the transport, it deasserts the busy signal. System deasserts send signals. Transmitter block diagram. How a transmitter transmits UART. It sends the data to the transmitter state machine. It has a priority generator. Okay. So from the transmitter state machine, a timer is there which resets a timer. Next bit is there, a count is there, move or 10 counter is there, which increment or decrement the counter. Shift rotate registers are there. Shift registers are there, which continuously shifts the bits. Okay, which rotate and shift the bits so that an output should be in a proper manner. Serial port is an UART. UART is nothing but an serial port. We are connected one laptop to the another or a hub to the network. Serialization data to be sent over a serial cable. Deserialization receives a data as the connections may be as shown in a figure. UART uses be commonly used for the internet access. UART, which is commonly used for the internet access. A serial cable is there which goes to the modem, and from the modem up to the modem, a phone line may receive from a phone line. Okay, and a phone line from there, it is in a ISP, internet service provider. It goes to the internet servers are there for a particular users. So in this way, uh, internet can be accessed on a terminal or a computers via by using a UART. So questions may be how fast we can run, what are the limitations, why do we need to start and stop bits, how many data bits can be sent, baud rate, no priority. These are some of the questions which maybe we are discussed in these lectures. Thank you friends for watching the video.